Hi everyone, Happy New Year to you all and welcome back to Life Technologies YouTube channel. So this is another episode of our Huawei Lab simulation series. Remember we have had multiple episodes demonstrating how to configure and troubleshoot different networking protocols or different networking technologies on Huawei routing devices. So if you're interested in learning how to operate and manage Huawei routing and switching devices, kindly check out this series on our YouTube channel. And just a kind request that if you've been watching these videos and you are yet to subscribe to our channel, kindly hit that subscribe button and stay tuned in for more upcoming videos. So in this episode, we'll be demonstrating how to perform basic routing port between BGP and OSPF protocols. So we know that these are very common networking protocols. BGP commonly used as an EGP, external gateway protocol to connect different autonomous system, and then OSPF, this is an IGP that is used to route within an autonomous system. So when you have these two protocols running on your network, they interact at some point. You need to have routes exchange between BGP and OSPF. So this is what we'll be demonstrating, how you can import routes from BGP to OSPF and also how you can import routes from OSPF to BGP. So you can see that from this topology, you have two autonomous systems. You have AS100 and AS200. So between AS100 and AS200, we'll be configuring BGP between these two routers, router R1 and R2. And then in AS200, we'll be having OSPF running between router R2 and R3. So for R1 and R3 to communicate, we need to perform some route import on this router too. So we need to import OSPF routes to BGP, and we also need to import BGP routes to OSPF, and then we'll have end-to-end connectivity between the routers in the different autonomous systems. So this is the basic laboratory that we have. You can see from the ENSP, we have a similar setup, and we'll be configuring eBGP between the two routers R1 and R2, and then OSPF between R2 and R3, and we'll go ahead and perform route import between BGP and OSPF, and also between OSPF and BGP to ensure that we have end-to-end connectivity. So I have mentioned that this is a very common requirement when you have different protocols running on your network. You always have to perform some route import between different networking protocols that are running on your network. So to start with, we need to do some basic configuration. We need to configure the sysname. We need to configure interface IPs. And once we have done that, we can now go ahead and do the BGP configuration and also the OSPF configuration. Once our BGP and OSPF are up and running, we can now go ahead and do the route import between the two protocols. So we'll start from R1. So on R1, I will undo terminal monitor so that it doesn't disturb us when we are doing the configuration. Undo terminal monitor, and then I'll configure the sysname to R1. So we have to do the interface configurations. I'll start with loopback 0, and then IP address it's set to 1.1.1, mask is 32, that is okay. Then we can configure the back-to-back interface between R1 and R2. So this is on gig 0/0/0. We'll give it an IP address of 10.10.10.0. Mask is 31. So once we have done this, we can go ahead and configure R2, the interface parameters. So I will also undo terminal monitor, and then go ahead and configure the sysname to R2. Interface loopback 0. IP address will be 2.2.2, mask is set to 32. Then we can configure the back-to-back connection between R1 and R2 and R2 to R3. So interface gig 0/0/0, IP address will be 10.10.10.1, mask is 32. No, we need to configure the mask to 31. Then we can check this connection is 20.20.20.0. So I'll go ahead and configure interface gig 0/0/1. IP address will be 20.20.20.0. Mask is 31. So we have finished the basic configurations on R2. We'll go ahead and do configurations on R3. So R3, again, undo terminal monitor. We set the sysname to R3. Interface loopback 0. We set IP address to 3.3.3, mask is 32, and finally the interface to R2. The IP address will be 20.20.20.1, mask is 31. So we have finished basic configurations on both routers. We can test the ping from R2. So on R2, we can try to ping 10.10.10.0. That is okay. Then we can also ping 20.20.20.1. So the back-to-back connections are okay because our ping tests doesn't have any packet loss. So the next step is to now configure. We'll start by configuring OSPF in S200, and then we'll go ahead and implement eBGP between R1 and R2. So let's start from R2. So from R2, what we can do is we'll configure OSPF 10. We need to configure the router ID to 2.2. It is area 0, and then we can advertise the network that we want. So we want the loopback IP address and also the point-to-point connection between the routers. So the network will be 2.2.2. This one should be, that is the wildcard mask. And then network 20.20.20.0, it should be 001. That is okay. We go ahead and do the configurations on R3. So it is OSPF 10, router ID, this is 3.3.3, then it's area 0. We advertise the loopback IP 3.3. The wildcard mask should be 000, and then the point-to-point connection. So display this, you can see the OSPF configuration. Let's check the OSPF status, display OSPF. This will be OSPF peer. You can see that we have a peer. You can use the brief command. You can see that the state is full. So if we try to ping from R3, we can try to ping 2.2. You can see that we have reachability between the two routers via OSPF. Can display IP routing table. You have OSPF routes. On R2, you can also verify that we have OSPF routes. Display OSPF peer brief. You have the neighborship. Display OSPF routes. You also have the routing information. So from here, we have OSPF configured in S200. Now we need to establish eBGP connection between R1 and R2. So we'll start from R1. So R1 is BGP 100. And then we are configuring peer 10.10.10.1, just using the point-to-point connection. And then the AS number is set to 200. Display this. Then on R2, BGP 200, it's peer 10.10.10.0. AS number is set to 100. So we expect the BGP peering to come up. Display BGP peer. We need to give it some time. It takes around 30 to 45 seconds for the peering to come up. So you can see that our peering is now up between R1 and R2. But if we check the routing table, display IP routing table, you can see that we don't have any routes that are coming in from BGP. If we also check from OSPF, if you also check display IP routing table, we don't have any networks. On this R1, we can advertise the loopback IP. So I will run network 1.1.1.32. So we expect to get it on this R2, display BGP routing table. You can see that we have 1.1.1 coming in from BGP. Display IP routing table. We have an eBGP route that is coming in, so that is okay. But when you check on R3, display IP routing table, you find that we don't have any BGP route that is coming in. And also on R1, we are also not getting any OSPF route because by default, there are no route import between these two protocols. Like we will not have any OSPF route imported to BGP or BGP route imported to OSPF unless you configure it manually. So this is what we need to do on R2. At the boundary, this is where we do the route import between the two protocols. So there are different ways you can do this. The first one is just importing everything. You import all OSPF routes to BGP and you also import all BGP routes to OSPF. And this is normally not recommended in a production network, but we'll just demonstrate to you how you can do this. But the next option, the better option, is you can do route import between the two protocols using routing policies. So you control what is imported between OSPF and BGP. Remember, BGP comes with so many routes. So you don't want to import all the BGP routes. For example, if this is a connection to the internet, you don't want to import all the BGP routes from BGP to OSPF. So you need to do the best practice of using route policies to control what you want to import between the protocols. But in this lab, we'll just show you how to do the route import, and we'll be importing everything from OSPF to BGP and also from BGP to OSPF. So for us to import BGP routes to OSPF, it's very simple. We need to be under OSPF 10, and then you can run the command import route. When you run the command import route, you can see that we have different protocols. You can import direct, you can import SIS, you can import maybe another OSPF process, you can import static routes. But for us, we need to import BGP routes. When you run import route BGP, you see that we have a route policy. You can set the cost, you can set the type. But for this lab, we are just going to import all the routes, all the BGP routes as they are. So we don't use the route policy. But in the next episode, I will be demonstrating how you can use route policy to control the route import between the two protocols. So this is it. I display this. You have the command import route BGP. So once you've done this, we expect to be getting display IP routing table. You can see that we have these type of routes, OSPF external route. So we have this route that is now coming in from BGP to OSPF. When we check, remember we have just done one way. We have imported BGP routes to OSPF. For us to have end-to-end communication, we also need to import OSPF routes to BGP. So same on R2. Now I'll go to BGP 200, import route OSPF. So you can also use a question mark. You see that you have multiple options: direct, SIS, OSPF, RIP, static, or user network routes. So you can import route OSPF. You see that you can specify the process ID. So we are importing import route OSPF 10. And then you can set the MED, you can set the route policy, but as I've mentioned, we are just doing basic route import. So we are importing everything from OSPF to BGP. So when you hit enter, you can check the configurations, the command, and then we now expect to be getting the routes from display IP routing table, you can see that we are now able to get some eBGP routes. We are getting 2.2.2 and 3.3.3 from OSPF to BGP. So if we try to ping 3.3.3, you can, let's see, this is set to the next hop of ping hyphen a 1.1.1 3.3.3. So remember, when you ping directly, it will take the outgoing interface at the source, but you need to specify the source, and then you should be able to ping, because this 1.1.1 it's known, or it's in the routing table of R3. If you display IP routing table again, you can see that you have 1.1.1 here. So that's why we need to source for us to be able to ping from R1 to R3 using the loopback IPs. So this is how simple it is to perform a route import between OSPF and BGP. You can see the commands. In BGP, we need to import route OSPF 10. And in OSPF, display current configuration OSPF. In OSPF, we also run this command import route BGP, and that is it. So import route BGP, import route OSPF, the OSPF process, and that is it. You will have performed a basic route import between two routing protocols, BGP and OSPF. But remember, with this, we have imported everything, which is not the best practice. So in the next episode, I will be demonstrating how to use route policies to control what you want to import between these two routing protocols. I hope you've enjoyed this session, and see you in our next episode. Bye.